All right, let's talk about the final exam itself. So tomorrow, all of tomorrow's class is going to be focused on just kind of going back through what we've done over the past 5 weeks and just kind of patching holes. So what I would really encourage you to do tonight is, other than preparing for that double quiz, kind of go back through the first 3 exams, go back through those other 7 quizzes, and just kind of figure out, okay, where am I still having difficulty? What kinds of things do I want to focus on? Because that's really where we're going to spend a lot of our energy tomorrow after that quiz. Um, um, and I've got Kahoots and stuff at the ready if we want to go that direction for review as well. But the exam itself, 110 minutes, that's an hour and 50. Cannot give you any more than that. That is what is mandated by the ACS. It is going to be 70 multiple choice questions. The Scantron is something I will provide you, so don't worry about having to go get that. Inside of the booklet, there is going to be a periodic table and an equation sheet. So we will use their version of the periodic table just so that you don't get messed up in trying to calculate molar masses or something like that off of a slight decimal difference or something like that. But I will also provide you with the equation sheet that you've been using on all of the exams as well. I'll also provide you with scrap paper because you're not allowed to write in the exam booklet itself. Topically speaking, you'll see that with limited exceptions, everything that we've talked about over the past 21 days is going to be featured in some kind of way or shape or form. So there is a section, and one of the nice things, I will give credit to the Exams Institute. They basically chunked out the exam topically. So there is a kinetics section where there are 8 or 9 questions in a row that are just about kinetics. There's a equilibrium section where there are a number of questions just about equilibrium. So when it comes to kind of the approach that you would want to take, there is rhyme and reason to it. And so you can kind of be like, okay, I'm in the kinetics section. Let me look at my equation sheet at the kinetics part of that equation sheet to give me some ideas and some inspiration. So kinetics is in there. So you're going to want to focus on things like rate laws and so on. As far as things like mechanisms, I don't think you're going to see too much in the way of like derive this mechanism, but you are going to have to understand, that mechanisms exist and, do things like reaction coordinate diagrams for determining how many steps are in a mechanism or what the rate determining step in the mechanism is, what activation energy is, those kinds of things. Equilibrium, the ACS mandates that you only non-programmable calculators are permitted. So from an equilibrium standpoint, know that everything is either going to be something that is quadratic formula solvable or something that you can break down with the 5% rule. So no cubics, no crazy kinds of equilibrium kinds of calculations going there. Because of the parameters, understand it's going to be very straightforward. For acid-base chemistry, in addition to Ka, Kb, pH, pOH kinds of calculations. You're also going to make sure that you're very familiar with the definitions. What does it mean to be an acid base under the Bronsted-Lowry theory? What does it mean to be an acid base under Lewis theory? How can you evaluate the strength of acids to each other? Out of chapter 15, I chose to kind of break things down topically instead of just saying all of chapter 15. So you're going to need to know something about buffers. You're going to need to know how to calculate buffers. You're going to need to know what buffers do. You're going to need to know how buffers can be manipulated. For titration curves, you're going to need to know how to do titration calculations in terms of things like equivalence point, but don't expect any kind of long form titration curve calculation like what is the pH at 15 milliliters of sodium hydroxide added to this. Be able to interpret graphs of titration curves. For solubility equilibria, do you know what KSP is? Do you know how solubility is affected? Do you know what the common ion effect is? You're probably not going to see a whole lot of KF stuff here at all, so don't worry about the complexes kind of angle in solubility, other than just understanding that complexes will increase solubility qualitatively. Out of thermodynamics, do you know how to calculate delta S? Do you know how to calculate delta G? Do you know what spontaneity is? Do you know the relationships between spontaneity and the equilibrium constant? Same deal with electrochemistry. Do you know how to calculate E? Do you know how to calculate standard cell potentials? Do you know the relationship between E and delta G and the equilibrium constant K? There are a couple of questions about intermolecular forces and phase diagrams. This is stuff that we covered in 105, but we rehashed, especially as we were talking about solutions here. So, do you know what the difference between London forces and dipole-dipole is? Do you know what hydrogen bonding is? Do you know what a phase diagram is? Do you know how a phase diagram is changed when we go from pure solvent to solution? And so now we're getting into that chapter 18 stuff. Do you know how to calculate different concentrations like molarity, molality, mole fraction, mass percent? Do you know freezing point depression, boiling point elevation, osmotic pressure? You know what those things are? Do you know how to calculate them? One thing that will be absent out of chapter 18 is solid state stuff. Solid state is not mandated by the ACS. The reason we covered it is because it's mandated by the state. We want this class to transfer, so we had to put in solid state calculations because that's what they wanted us to talk about. And then finally, nuclear chemistry. Most of the stuff that we're talking about with nuclear chemistry is the stuff we talked about yesterday. Transmutation reactions, recognizing the 5 types of decay, being able to balance those equations, being able to answer relatively simple questions about half-life. Understanding that half-life in nuclear chemistry is a first-order kinetic process. So if we were asked a more complicated question about half-life, we would know that we need to use the natural log first-order equation. So that is the topical breakdown. And yes, that is pretty much everything that we've covered here since we started. Let me give you a chance to ask questions here. Is there anything that you want further clarification over? Is there anything that you are unsure of as we kind of start to take a look at this? No, you won't be allowed to use your graphing calculator. No, no graphing calculators, none at all. we don't report our scores to the ACS, so if we did, we would have to follow their protocol more strictly. But we don't, so we're not going to. But that being said, since that is the parameter, then we have to understand what that means. That means that the test questions are written in such a way that they have to be able to be solved without a graphing calculator, which means quadratic formula, simple algebra, no complicated kinds of K expressions. So you're not going to see things like 4x to the fourth multiplied by 3x cubed over 2x squared. You're not going to see that unless we have some way of estimating all that stuff. Like if we were told what one of the products is, and we can derive all the other ones. Or it all magically kind of shrinks down where if I take the cube root of both sides, suddenly I'm left with, 25 is equal to x squared times 5. And then you go, oh, okay, I can do that. So no, because the test is written in that kind of way, we have to know that the expectations are that you be able to solve it simply. So, algebra 2 is pretty much the extent of what you would need to know from that standpoint, at least in terms of what is expected. All right, other questions? All right, this final guide is published in your final exam folder, along with these final exam practice questions. I showed you these before, but these are questions that we have pulled off of old ACS practice exams, so they were available publicly at least for a while. They're not out there anymore, but we do have them. And so you can get an idea of the kinds of questions that you could be asked and what kinds of things you could be expected to know. And then the answers are here so that you can check yourself against those as well. All right, anything else that we want to talk about today?